Hello students, today we are going to see a topic on railways in which we are going to cover 3 points: gradient, grade compensation on curves, super elevation. We will see what is gradient. Gradient is nothing but a slope which is provided on the railway track. So the amount of slope in longitudinal direction of railway track is called as gradient. This is the definition. Gradient are provided to negotiate the rise or fall in the level of railway track. Rising gradient rises the track in the direction of movement, whereas falling gradient causes the track to go down in the direction of movement. A gradient is represented by distance traveled for a rise or fall of 1 unit. So normally it is written 1 in x or 1 in n. So supposingly, for example, 1 in 100, in which 1 is vertical and 100 is our horizontal distance. So this diagram will explain you very nicely what is gradient. So here in this case, this is 1 in 20. So 1 meter is your vertical distance and 20 is your horizontal distance. The slope which is from the slope from where the railway is going to travel, that is called as your gradient. Why gradient is provided? To provide uniform rate of rise or fall as far as possible, to reach various stations located at different elevation, to reduce the cost of earthwork. So here we have 4 types of gradients: ruling gradient, momentum gradient, pusher or helper gradient, gradient in station yards. So this depending upon the slope, that this different gradients are there. So this rolling gradient is the having steepest slope, or we can say maximum gradient which may be permitted on the section of the track. Okay, so in India, the plain area, rolling gradient is provided 1 in 150 to 1 in 250. In hilly area, it is provided 1 in 100 to 1 in 150. Then comes your momentum gradient. Momentum gradient is steeper than rolling gradient. That is to overcome the momentum gathered while having a run in plane or falling gradient. We will take example. These are the 2 examples in which this train is going to. This is a falling gradient. Due to falling gradient, there is a kinetic energy gathered. That energy is used for the moving train to enable the train to overcome steeper rising gradient than the rolling gradient. Okay, so this rising gradient is nothing but your momentum gradient. So here one more example. Supposingly a cycle is going to ride on a falling gradient. So there is a large kinetic energy which is gathered, and this large kinetic energy is used for the bicycle to overcome this rising gradient. Okay, so this rising gradient is nothing but your momentum gradient. Then comes your third one, that is pusher or helper gradient. Gradient steeper than the ruler gradient, requiring extra locomotive. This is called as pusher gradient. It reduces the length of railway section. It also reduces the overall cost. Example can be given here as in Darjeeling railways, 1 in 37 pusher gradient is used on Western Ghats. BG tracks and NG track is 1 in 25 is provided. Then gradients at station yards. Normally gradients at station yards is provided very low or level, so that to prevent standing vehicles from rolling and moving away from the yard due to combined effect of gravity and strong winds. Also to reduce the additional resistance forces required to start a locomotive to extent possible. And minimum gradient from drainage consideration. In India, maximum gradient provided on section yard is 1 in 400 and minimum gradient is 1 in 1000. Then grade compensation. What is grade compensation? In curves, if a curve is provided on a track with ruling gradient, the resistance of track will be increased. Obviously, in order to avoid resistance beyond the allowable limits, the gradient normally provided on this curve is reduced. That means actual gradient or actual slope is lesser than whatever ruling gradient is there. So this reduction in the gradient is known as grade compensation for curves. So in India, compensation or whatever curvature is there, there is permissible limit. So in BG track, it is 0.04% per degree of curve. In MG track, it is 0.03% per degree of curve, and NG narrow gauge track, it is 0.02% per degree curve. Safe speeds on the curve. There is permissible safe speed on the curve, which is given by this formula. V is equal to 4.3735 square root of r minus 67 for BG and MG, and for narrow gauge it is V is equal to 3.65 square root of r minus 6, where V is your velocity in kilometers per hour and r radius in meter. This negative course safe speed is depends on following factors: gauge of the track, radius of the curve, amount of super elevation. Then we will see what is super elevation. So everybody knows in mechanics we have studied super elevation. So super elevation is sometimes called as cant also. When a track moves around a curve, it is subjected to centrifugal force acting horizontal at the center of gravity of each vehicle radially away from the center. This increases the weight on the outer rail. To counteract the effect of centrifugal force, the level of outer rail is raised above the inner rail by a certain amount to introduce centripetal force. This raised elevation of outer rail above the inner rail at the horizontal curve is called as super elevation or cant. So there is the outer rail is raised. Okay, this is called as super elevation. So in this figure, we can see that what is super elevation. Outer rail is raised due to inner rail. Here the picture is very clear. We can see that super elevation is nothing but outer rail and rail is raised and inner rail is lower. So the difference in elevation between outer rail and inner rail at horizontal curve is called as super elevation or cant. It is denoted by E. Objective of super elevation to neutralize the effect of centrifugal force, okay, and also to equal distribution of wheel loads, providing smooth track, and also to reduce wear and tear of rails and rolling stock. Okay, what is the formula used for super elevation for BG, MG and NG? If V is the speed of the vehicle in kilometers per hour, R is the radius of curve in meters, G is the gauge of track, then super elevation E is given by GV square upon 127 R in meters and GV square upon 1.27 R in centimeters. So here you can see the super elevation provided. Outer rail is raised, inner rail is lowered. Then we shall cant deficiency. What is the meaning of cant deficiency? In simple word, cant deficiency is nothing but the difference between equilibrium cant minus actual cant. Okay, means what? What is the meaning of equilibrium cant? Equilibrium cant is nothing but whatever super elevation you are going to design, okay, according to the nature of the curve, and actual cant. Okay, actual cant means whatever you are going to provide. So in practical case, what happens? Equilibrium point is provided on the basis of equilibrium speed or average speed of different trains, but this equilibrium cant or super elevation falls short of that required for high speeds trains. This shortage is called as cant deficiency. So due to high speed trains, whatever equilibrium cant is not provided, it is provided with lesser amount. That is called as actual cant, and the difference between that is called as cant deficiency. So maximum value of cant deficiency prescribed by Indian Railways is for BG it is 7.6 centimeter, MG it is 5.1 centimeter, and NG narrow gauge it is 3.8 centimeter. Thank you very much.